Hi, I'm Peter Cross, and I'm the Graphics and Game Dev Community Engagement Lead at Intel. And we're very proud to be a sponsor here at the Nordic GameCon event. Last week, we announced our AI GameDev Toolkit for Unity, which will be releasing in a couple of months. We're excited to be able to show you a demo of this groundbreaking new plugin that brings the power of AI and machine learning to game devs around the globe. This plugin, primarily powered by the Intel Open Vino, was developed in conjunction with members of our Intel Graphics Innovator program. One great part of this toolkit is it allows for integration with popular Unity assets like the powerful world-building tool Gaia. Before we get to the demo, I wanted to remind folks to visit our newly revamped Game Dev page and to join the Intel Game Dev program to get access to tools and tutorials that will help you imagine, plan, and design your games. This page offers access to free libraries, performance analyzers, and other tools that help you code more efficiently and optimize your game for improved performance on Intel architecture. In addition, it provides access to exclusive code samples and go-to-market guides written by game developers. Lastly, we invite developers interested in exploring cutting-edge new technology to apply to be a part of our Intel Software Innovator program. And now, I'd like to introduce our innovators who created this amazing demo. Adam Goodrich, who also happens to be the founder of Procedural Worlds, and Christian Mills, a leading expert on machine learning in the game development universe. Take it away, guys.
Thanks, Peter. It's an exciting time to be a part of the games community and an Intel innovation partner. At Procedural Worlds, we specialize in the development of tools that use what we call artist-driven procedural generation to make beautiful and functional environments for games. We call it artist-driven because while we feel that procedural techniques are awesome, the real magic comes from you, the artist. Our tools then do the heavy lifting and dramatically reduce the time it takes to make your environments, leaving you to focus on making your games. If you think about the amazing advances happening in machine learning, it's pretty clear it'll be coming to the games community in a significant way in the coming years. Today, we are pleased to announce that we'll be creating a special version of Gaia for AI and contributing it to Intel's AI for GameDev Toolkit. The AI GameDev Toolkit leverages OpenVINO to unleash the power of your CPU and your GPU to accelerate the use of AI and machine learning in your games. Some of the use cases for machine learning in your games include content creation, generative world and art creation and automated optimization, graphics quality with upscaling technologies like XeSS and render optimization, smarter NPCs with speech and behavior powered by reinforcement learning, and game assistance with background and noise removal, anti-toxicity and anti-cheat. Gaia is deeply integrated into Unity and makes it easy to create worlds within which to release your AI creations. And today, I'd like to give you a little demonstration of how to create a world with our tools, and then to show off some awesome AI samples showing style transfer and object detection created by the amazingly talented Christian Mills. So let's do a little demo of creating a world with Gaia. The typical workflow with Gaia starts with the Gaia Manager. Gaia Manager has a wizard which takes you through project setup, world creation, runtime creation, and then the steps that you need to build and deploy your world. The Gaia wizard allows you to choose the size of your world, the target environment for your world, the target biome for your world. A biome is a set of assets, textures, models, and so on that are procedurally applied into your world, and then the target workflow. You can either do 100% manual stamper or completely procedural with the world designer, and in our case what we'll do is we'll procedurally generate with world designer, then manually change with the stamper. So let's create our world designer component. So the first thing we'll set up is the size and settings for our world in our world designer. So we've currently got a 1 terrain, 1 kilometer square environment. We could actually go into these settings and instead of doing 1 terrain tile, perhaps do 20 terrain tiles. What we've got here is a 20 by 20 world, which is 20 square kilometers and 400 terrain tiles. And what we're showing is a low-res preview of the overall world. Now in the interest of speed, I'm just going to stick back to 1 tile and then hit the randomize stamps button. And there we've got a new world. The purpose of the world shape panel is to set up the basic structure of your world. Think of it as the underpinning shape of your continent before Gaia does its magic on top. The world details the way in which we then fill your world with different types of features. So what we can do is we can increase certain features relative to certain other features. And then when we go randomize stamps, Gaia will generate a different version of your world every single time. This makes it quite easy to iterate until you find something you like, and then we can go and manually add additional detail later. So let's take that as our base and hit generate world. All right, here's our base world. Let's go and see what's going on here. Now at the moment, it doesn't look like much, and we're going to manually modify this. So the first thing I'm going to do is go back to my Gaia manager and add my runtime. Hit the create runtime. Gaia will ask if we want to go ahead. We'll just go yes. There we go, we're done. So Gaia has set up the basics of our world for us. And now what we want to do is go and customize it. It's a fairly small environment. I did that just to make things go faster in this demo. So the next thing I'm going to do is add some more land to our world. So to do that, I'll go back to Gaia. I'll go to Advanced Tools and add our stamper. And just close that. The stamper is basically the thing that does a lot of the magic in Gaia. What we've done here is we've taken a height map of an interesting environment and we've placed it into a tool that allows you to visualize and see where that would be in your terrain. So let's just make this a little smaller, perhaps make it a little higher, and move this around. Now this one is not particularly good for what I'm trying to do here. So let's try mountains, for example, and move our mountain to where we would like it to go in our scene. Mountains perhaps is a bit high. Let's have a look at, say, plains. Just choose some of the different plains here. Go with that one. And what I'm going to do is show you another very powerful aspect of Gaia. So as you can see here, it doesn't actually work. It's quite a substantially different environment from the one we've got here. So what I'm going to use is the masking system that comes with Gaia. First thing I'll do is add a distance mask. And then I'll modify the stamp until I feel that it works just right in the scene. The next thing I'm going to do is use Gina to add some details and some roads and some villages and so on into our environment here. What I might do is put something just here. So let's go to our villa, drag that into my scene. You can see a visualization of how big this villa is. It's quite big compared to the size of our island. So I'm going to shift click here. Now you can see that arrow. That is the direction of the entrance of the villa. And I'm going to put this villa just here. And watch what happens. Notice that what we've actually done here is we've flattened the terrain underneath the villa and we've now placed quite a sophisticated little environment. Now let's put something else, say, on the other side of the island. And let's do perhaps a little farm. Still quite large. Maybe we'll put our church in there instead. Yeah, that's not as big. Again, we've flattened the terrain and we've now put this nice church in our environment. Now, we've used some sample assets, but you could use whatever asset you like. Gina comes with a whole bunch of tutorials that show you how to use it. The next thing I want to do is actually connect this environment together with some roads. So let's go and add a road spline. To add our roads, we can go down, choose where the road will go. Now I'm going to use the pathfinding capability of the road system. I like the pathfinding system because what it tries to do is find the minimum grade that the road can traverse along, and what you tend to get is a more natural type of road. So let's go in here, hit control, and you can see we're placing the road in, moving along the side of the terrain here. I'm going to cut this one straight into the side of the hill. Oh, no path found. So if you get too significant a grade, it will actually tell you, no, we can't do it. You can relax the constraints, but in this case, let's just see. Maybe if we choose a slightly different path. No, it's not going to let me. So let's change the max grade and increase it slightly. There we go. We found our way. And now let's cross the river. Bring it over here, click to there. Now, because we're having a problem getting across our river here, we're going to turn off pathfinding and do it manually. There we go. Instant bridge. And we'll just finish it off and run it up here. The next thing I'm going to do is carve the road into the terrain. By default, the terrain doesn't work with the road and the road doesn't work with the terrain. So let's fix that. I'm going to select my carve extension and activate it. And what you can see here is a preview of how we'd modify the terrain to support this road. So if I just run a quick carve, you can see that we've cut the road quite steeply into the terrain. But I like something more organic, so I'm just going to undo that. And then I'm going to increase the shoulder. So we'll blend that out a bit. And then I'm going to add some noise. And you can see we've actually modified how that road will be generated. So you can play around with the noise settings to add a little bit more interest into the carve, and then you can hit carve. If I look at it again, now we've got a more organic embedding of the road into the environment. Okay, that's looking good now. Let's add some lights to our road system. So I'm going to select my road spline and I'm going to drag and drop my street light onto the road. Now the street light is just another genus spawner. And you'll notice here that the flow rate is quite high, and this is showing where the street light would spawn. Now we don't want that many street lights. So let's go and change our flow rate to say 20. And now you can see the street lights are further apart. Let's change our offset in the X direction by 4. Now the road lights are off the edge. And let's go align to spline. Align. Actually, I'll demonstrate it to you. Let's spawn. So what we've done is we've now put road lights all the way along our road here. Now you can see that they're spawned in all sorts of directions. We can go align to spline, align children, and then set our rotation offset. And now they are perfectly aligned along our road. The next thing I'd like to do is put in a fence. Now the way we make fences is we add a spline and then we drop our fence object onto the spline as we would normally. So what I've done here is I've sped it up and added quite a few fences into our scene. Okay. We've added some fences. Now let's paint in some interesting trees. And I'll just paint my trees in. Rather cool. So we've added some buildings, we've added some roads, we've added some fences, we've added some ferns. I've given you a sense of some of the things that we can do here. Now, let's finish this off. I'm going to go back to Gaia and our biome system. Actually, before I finish it off, I'll show you some of the powerful capabilities of the biome system. So the biome system is based on the concept of a spawner, and a spawner is how we apply different resources into your environment. So in this case, we've got a texture spawner, and it's responsible for taking these textures and adding them into your scene. Now, let's show you a little bit of the power of this. I'm going to open up this moss spawner. I'm going to visualize it. What you can see is this particular texture would appear only in these different areas. And if you wanted to change this, for example, we've added a bit of noise to break it up, you can see how the mask changes. So that shows you exactly where this will go. If you turn off the slope mask, then this thing would go everywhere, which of course we don't want, but it's a great way of visualizing. And the visualization system in Gaia is extremely powerful. We have many different types of masks which you can use to control where and how resources are applied to your scene. So I'll pop that back in, and I'll actually just go back and spawn the whole thing. Let's watch some magic happen. And we're done. We have filled our entire environment. We've textured it, we've added all sorts of plants, and there's a lot of material now in Machine. Now notice here we've got a bit of a mixture because we manually painted that in with Gina, and we finished it off with Gaia. It's quite barren over here. If we wanted to, we could just go in and paint some more bushes. But let's press play and see what we ended up with. One of the cool things that Gaia has is a thing called photo mode, and what you can see me doing now is going in and changing the visual settings of the scene to customize how it looks. It's actually rather fun, and you can use it also to take some awesome screenshots of your environment. And now, here's the scene we created for our AI fly-through. I'm going to use another tool of ours called Pegasus, which makes it easy to create fly-throughs, and I'll show you how easy that is. I'm going to start my scene. Okay, so here I am in the scene, and I've got a little reticule here, and this is exactly where my camera is going to look. So I might start looking initially at the deer, and I'm going to hit P. You'll notice we actually put a block in the scene. Then I'm going to stay looking at the deer, and then continue on and perhaps look up at this car and continue along our merry way. Now, maybe looking more at the car as we go past, and then maybe coming up a little bit, looking down here, and maybe look at our stag here, and then as we head back down here, and then down through here, and then yeah. All right, now let's go back and actually create the fly through. So I can hit my Pegasus capture and go create Pegasus, and then what Pegasus done is it's created this rather cool little fly through. Now I'm just going to slow its speed down a bit to say 4 meters per second, and then run this. But there we're looking at our deer, and we'll start to look up at the car. Looking rather cool. And we'll start to climb and look at our stag. Yep, and then heading on, moving down here and starting to look back along the road. Very, very handy for making quick fly-throughs and awesome for doing offline renders. Okay, now that we've finished world building, let's explore some AI. We'll be exploring the potential of combining machine learning inference tools like Intel's OpenVINO Toolkit with real-time development platforms like Unity and Unreal. As a demonstration, we will walk through an early prototype with a couple of different ML models created from a Gaia scene on an Arc Alchemist GPU. First up is an object detection model. These models take in the current rendered frame and identify game objects in the scene. For each detected object, the model outputs the screen coordinates for the center of the object, the height and width of a bounding box that would contain the object, the type of object, and a confidence score in the prediction. The output model is returned to Unity in an array, which can be readily used for other parts of a project. These models can be trained to detect arbitrary types of objects provided there is sufficient training data. They can even be trained to detect specific people, expressions, gestures, or poses. The models used in this tutorial have been trained on the COCO, Common Objects in Context, dataset, which contains 80 different real-world object categories. They have not been trained with any video game footage. The model architecture used in this demo is the YOLOX model developed by Megvii. YOLOX builds on the YOLO, You Only Look Once, family of real-time object detection models and implements multiple recent advancements from object detection research. However, the plugin can be adapted to work with other popular object detection models like YOLO v5. The models are available in a variety of size, each with different trade-offs between speed and accuracy. Training these models from scratch can be time-consuming, however pre-trained models can be fine-tuned on custom datasets relatively quickly using online tools. The next model we'll demonstrate is a style transfer model. This type of model is trained to take in an arbitrary image as input and apply the style of another image. The model is trained on a large dataset of arbitrary images to help it generalize in different scenes. The model used here is a basic implementation that is not trained for consistency between frames. This results in a flickering effect as the model detects nearly imperceptible differences in each frame that affects the resulting image. We are exploring multiple potential solutions with different quality and performance trade-offs to resolve this. These style transfer models currently require powerful GPUs. However, combining them with upscaling solutions like XeSS can make these models accessible to a wider range of performance tiers. Future versions of this product could include newer style transfer models that can take in arbitrary style images at runtime and blend different styles in a single output. These more advanced models take significantly longer to train, but only need to be trained once. And let's enjoy some of these examples of style transfer. As we take a moment to view these amazing style transfer videos, I would like to reflect on what we have demonstrated today. First, we announced that a special version of Gaia will be created for the AI GameDev Toolkit and that it will contain integrations with the toolkit to make it easier for you to create cool environments in which to get started on your own AI journey. Then we showed off some of the power of our world creation tools by using Gaia, Gina and Pegasus to create worlds and fly-throughs. And while not shown, We also have other tools that handle the acceleration and streaming of Earth-scale environments with frame rate improvements of between 2 and 50 times what Unity can do by itself. Then we showed off some amazing work from Christian Mills as he used his Alchemist GPU to deliver an early demonstration of real-time object recognition and a range of interesting style transfer examples. And finally, we would like to finish with an announcement and a quick trailer for MetaWorlds, our new social computing platform for work and play. MetaWorlds is all about empowering creators to create, share, connect, and transact. In other words, to make a living doing what they love. MetaWorlds allows anyone to share assets, games, and even create their own MMOs on demand, and we will be using MetaWorlds as a platform to allow you to share and perhaps monetize your own creations in the future as well. Thanks very much for watching, and here is MetaWorlds.